So today we are talking about operations with radicals. When I say operations, I'm referring to your addition, subtraction, multiplication, division. So doing math essentially with the radicals themselves. Let's take a look at this notation. Don't try to overcomplicate this part. Don't look too deeply into it. Here we have the nth root of a times the nth root of b. What you need to focus on is that the n's are the same. That's what's important. If they have the same n, called the index, then you can actually multiply a and b together, as you would be tempted to, and just put them under the same root. So I'm going to write that out. If the radicals have the same index, again, that is just what the n is, then you can multiply. Let's take a look at our first example here. Number 1, here we have the square root of 8 times the square root of 3. Again, just quickly verify that that index is the same before you jump in and multiply. So we'll multiply those together. 8 times 3, that's 24. Now we're not just going to box that up and move on. You guys know how to simplify radicals, so the standard and the expectation from here on out is any time you end up with a radical that can be simplified, you will simplify it or it is wrong. So right now, stopping here, you'd be losing a point, so this would probably be a 2-point question. You'd be losing half the credit because you didn't simplify. So let's break down the 24. And just to keep my work consistent, I'm going to do that separately underneath and just keep that for just nice answers only. So we have the square root of 24. We'll break down the 24. Got a couple options here. I'm going to go 4 and 6 for that. Four breaks down 2 and 2. The 4 is gone. 6 breaks down 2 and 3. The 6 is now gone. And this is a square root, so we're looking for groups of 2. So we have a group of 2's down here. That's just going to make a nice 2. And then the square root 2 and the square root 3, they can't be paired up because they're different numbers. So they're going to go back under the square root together. So this is going to give me 2 times the square root of 2 times the square root of 3. And of course, you can multiply these together and turn it to a square root 6. So 2 square root 6 is our final answer. Questions on number 1? Number 2. 2 cube root of negative 9 times cube root of 3. Again, just verify that they have the same index before you just dive right in and multiply. They do. 2 is just going to carry over into the answer. There's nothing else to multiply it by. And then we have the cube root of negative 9 times 3 is negative 27. Again, that 2 is going to carry over. And we need to break down the cube root of negative 27. So we'll take a moment and do that. First things first, negatives are allowed with cube roots, and they're always going to give you a negative answer. So go ahead and take that out and put it on the outside so we don't forget about it. and then we'll break down the 27. 27, our only options are 9 and 3. And then the 9 can break down again into 3 and 3. 9's gone now. Cube roots, we want a group of 3, and we do have one group of 3s. 3 3s. And there's nothing left. So the only thing coming out of this is a 3. So a negative 3 is our final answer for the cube root of negative 27. That means 27 is a perfect cube. And then we're going to add that to our answer above. 2 times negative 3, which of course will give us negative 6. Negative 6 is our answer. Questions on number 2. Number 3. Cube root of 6 times the square root of 2. I hope you caught on to it pretty quickly. These have different indexes. So that's exactly what I'm going to say. Different indexes. Can't multiply. If you can't multiply it, then you won't multiply it. That's it. Number 4. 3 times the square root of 5x squared times 4 square root of 20x. Same index, I can multiply. Let's multiply first and foremost. Now the two numbers on the outside will multiply like normal. 3 times 4, that's 12. And then on the inside, 5 times 20, that's 100. And then x squared times x, what is that going to give me? X cubed, thank you. Reminder, when you multiply x's together, variables period, the same variable, you will add the exponents. From here, we have 12 times, let's break down the square root of 100. Hopefully you recognize quickly that that is a perfect square and it's equal to 10. So we have 12 times 10. If you don't notice it, break it down. You'll still get 10 if you do it correctly. And then we have the letter, I should say, x cubed. X cubed, and we're taking the square root of it, so we're making groups of 2. Reminder, last set of notes I showed you 2 different ways to handle this. You can either write out 3 x's and make your circles, or you can do long division, very quick long division. This one, just for time, I'm actually going to write out the 3 x's because it's pretty quick, so I'll do that. 3 x's. Groups of 2, so I can make one group of 2 x's and I have 1 left over. So that means 1 x comes out and then 1 stays in. One out, 1 in. So I'll add that to my answer space up here, times x square root of x. And then we'll put all that together for our final answer. 12 times 10, that's 120. And then we'll just attach the x square root of x at the end. Questions on 4? Number 5. Bigger numbers, more variables involved. Square root on both. Again, check that first before you proceed. So we can multiply. 12 times 15, that's 180. X to the 4th times x squared. Again, be careful. This is not going to be 8. It's 4 plus 2 when we do the multiplication. So it's x to the 6th. Same thing with the y's. Y squared times y cubed, we're going to add 2 plus 3 is 5. It's not going to be y to the 6th. We definitely have some work to do here, so we're going to start by breaking down the 180. Again, this is a square root, so we're making groups of 2 here. I can't remember if I've said this before, so I'm going to say it again. My trick for numbers that end in 0 is I automatically pull out a 10. It's a good starting place. Starting with 2, and in this case 90, you're on for a long tree. It will get you there, but take a while. So pulling out 10 is a good starting point. 10, and in this case 18 will be the other number. And then I'll break both of those down. 10 only goes one way, 2 and 5. 10's gone. 18, you have options. 2 and 9, 6 and 3, both good options. I'm going to go 2 and 9 this time. 18's gone. And one more time, 9 breaks down to 3 and 3. And now the 9 is gone. Again, making groups of 2 here. I'll start with my nice pair of 3's down here, giving me a 3. It's going to pop out. So far I have 3 times. I have another pair of numbers, this pair of 2's here. They don't have to be next to each other to be grouped together. The circle is just going to look a little less pretty. So this will pop out a 2. And then don't forget this lone 5 here. It's very easy to leave terms behind when there's a lot going on. So 3 times 2 times the square root of 5. Which will give me 6 square root of 5. So I'm going to start my answer up here with 6 square root 5 times whatever's going to come next. Questions on breaking down the 180 before I move on to the variables? First, we have x to the 6th to break down. Again, this is a square root. This time I'm going to go the division route because this divides very nicely. X to the, we're going to turn this into a fraction for the exponent, in over out, 6 over 2. And that divides nicely, just giving us x cubed. So I'll put that up here in my answer space. For the last one, I have y to the 5th to break down. Again, this is a square root. Here's where the work would differ for different people. If you prefer to write out 5 y's and make your circles, do that. If you prefer the division, because it's a bit faster, you can do that as well. Again, just to show both methods, I'm going to do the division this time. So first, I'll write it with the exponent again. Y to the in over out, 5 over 2. And then 5 over 2, that we know is not going to divide evenly. And we're not going to go into our calculator because that's not going to be helpful. We're just going to divide on the paper. 5 divided by 2. So ask yourself, 2 goes into 5 how many times? And you're going to say 2, thank you. 2 goes into 5 twice. 2 times 2 is 4. Subtract, you get 1. We're left with 2 remainder 1. So that 2 remainder 1 means that 2 y's are going to come out and 1 is going to stay in. So we have 2 y's out, so that's y squared, and 1 stays in under the radical. So it's just 1y under the square root. And this will get added to my answers above. So times y squared square root y. Questions on that before I make the final answer? Making the final answer here. I'm going to start by putting a square root at the back, and I'll fill things in. Let's start with the numbers. We have a 6 outside of the square root, and it's going to be at the front because there's letters that are going to come after it. And then the 5 is going to go under the square root. So I've taken care of both of those. Next, the x cubed. That is going to go out in front after the 6. I'm going to go alphabetical order here. After that, the y squared is also outside with the 6. And then the y is going to go inside with the 5. Everything has been accounted for. This is my final answer. Questions on number 5? Flip it on over when you're done writing, please. Next page, division. Division works just like multiplication. Rule-wise, it's just division. So when we look at our rule here, we're looking for that same thing. If the ends match, then you can just divide A and B like you would be wanting to anyway. So exactly the same. If the indexes, again, that's referring to n, wasn't ready for a comma, match, then you can divide the radicals. So what you're going to find here is multiplying and dividing. They have the same rules. And then adding and subtracting, they have the same rules, but they're different from multiplying and dividing. So when we get there, that's just going to be the big obstacle for some, is just keeping those rules straight. Only 2 examples here. Number 6, we have the square root of 18x to the 5th over the square root of 2x cubed. Both of them are square roots, so we can divide them. First, we have 18 divided by 2, that's 9. X to the 5th divided by x cubed. What is that going to be? How many x's? Is that 2? Yes, x squared. So if you multiply, you're actually adding the exponents. If you divide, you're just subtracting the exponents. It works a similar way. We're not actually going to do 5 divided by 3. No one wants to do that. 9x squared is what we're left with. This is going to be a very nice answer. Let's break this down one thing at a time, starting with the square root of 9. I hope you recognize that. That is 3. It's a perfect square. So this becomes 3 times, and then we'll repeat that with the x squared. X squared, again, this is a square root here. Since it's nice, I'll do the fraction exponent here. X to the 2 over 2, which of course will just be x to the first. And let's make it a little better and just write x. Final answer, we'll drop that multiplication sign and just write a nice 3x. There you have it. Questions on number 6. Number 7. Now the division, cube roots this time. Both of them are cube roots, so we can proceed with the division. First, let's divide the numbers. 162 divided by 3, that is 54. Cube root of 54. We have an x on top and no x's on bottom. When that happens, don't panic. The x will just carry over into the answer. There's nothing else we can do with it. We have y to the 4th over y. Remember, this is a y to the 1st down here. So we're still going to do 4 minus 1 to get y cubed under the radical. We're going to break this down. First, starting with the 54. Reminder, this is a cube root. Make sure you're paying close attention to that. That will affect your answer if you treat it like a square root. Let's break down 54. It's got a few options. I'm sure most of us automatically think 6 and 9. That's where I'm going to go. 6 breaks down 3 and 2. And 9 breaks down 3 and 3. The 6 and 9 are both gone now. Reminder, cube root here, we're looking for groups of 3. We do have 3 3s here. So that's going to give us a nice 3. And then don't forget about this extra square root 2. It's all by itself, so it's going to join the answer under the radical. So putting these together, this is just 3 square root 2. Put that above in my answer. And then we have a couple variables to break down. Let's start with the x. X cube root. Now, just to really show what happens here, if you don't already see it, writing it as the fraction is not going to help, so I'm going to write out, this time we just have 1x. We don't even have enough x's to make a full group, so when this happens, in this case it's too small, it's just going to stay under the radical, and that's all you can say. So I'm still going to have square root of x up here, cube root of x. One more time with the y's. We have y cubed, again, cube root for this problem. This one's nice, so I'll use the fraction for the exponent. Y to the 3 over 3. And that's just going to give me 1, and I'm going to go ahead and just put y instead of y to the 1st. So I'll put a y up here in my answer. And we just need to put it all together. Set up a cube root in the back. We'll start with the numbers. 3 cube root of 2. 3 goes on the outside. 2 goes on the inside. Next, we have the x. There's only 1, and it's inside the cube root. And then the y's. There's only 1, and it's outside the cube root. Everything has been accounted for. This is our answer. Questions on number 7. Next section. This section's a bit different. You've never heard of this before. It's a concept that we have to introduce to you here mainly because those of you especially wanting to look to pre-cal, this is a very important concept. It's kind of an expectation. We'll definitely reteach it when it comes, but you're expected to know what this is when you come to pre-cal. So we're introducing it to you now. It's not going to be a big deal in Algebra 2. So there's a lot of questions surrounding this topic. I'm going to go ahead and answer them now. What is rationalizing the denominator? The what behind it, we can't have a radical on the bottom of a fraction. Can't have a radical on the bottom of a fraction. Because of that, we have a method called rationalizing the denominator to get rid of it. Why do we need to do this? Why is it important? It'd be like putting a decimal on the bottom of a fraction, which is something we never do. It's pretty much unheard of. Same thing. On top of that, calculations are easier if denominators are whole numbers. The how is the most important part, so we are going to write that one by hand. How we fix it, how we do this process. Multiply the top and bottom of the fraction by the radical to get rid of it. So we're going to do a couple of these problems. This process is pretty quick, much quicker than the other problems we've been doing. 8, 1 over the square root of 2. This is a very simple, straightforward problem. We have a square root, a radical on the bottom, not allowed. Let's get rid of it. So again, the how. Multiply top and bottom by that radical, so square root 2, top and bottom. Then we'll multiply straight across. 1 times the square root of 2, that's still going to be the square root of 2. Square root of 2 times the square root of 2 is square root of 4. Square root of 2 will still be on top. And then, again, I hope you recognize the square root of 4 is just going to give us a 2. And that's it. Reminder, square root's not allowed on the bottom. On the top, perfectly fine. It is impossible to completely get rid of it from the fraction, so the only thing we can do is make it better by putting it on the top instead. Number 9, slightly more complicated type of example you might see. And this one is just a big emphasis on following the directions. The directions say multiply top and bottom by the radical, so you're not going to multiply top and bottom by the 5 as well. Just the radical, which is square root of 3x. If you multiply by the 5, you're just going to make more work for yourself. On the top, 2 times square root of 3x, just put it together. On the bottom, carry the 5 over. Square root of 3x times the square root of 3x. Multiply. 3 times 3 is 9. X times x, there's 2 there, that is x squared. Now we definitely can simplify. If you still have a radical on the bottom after that, there's more work to be done. Top will stay the same, 2 square root of 3x. Bottom, I'll carry over the 5. The 9, square root of 9, I hope you're well aware again, that's 3. So this is 5 times 3. X squared, reminder, this is a square root. So if I were to do the work and actually write that with the 2 over 2, it's just going to be x. Before I write my final answer here, the big lesson to take away from this is when you multiply a radical by itself, the radical is going to be gone, square root specifically. The square root's going to be gone, and what was under it is all that's going to be left. So if you notice this from the jump, you can skip this middle step and jump from here to 5 times 3x. Works every time with the square root. The only way I can make my answer better is to multiply the 5 and the 3 and turn it into a 15. So we now have 15x on the bottom, and that's all we can do. That's our answer. Questions on rationalizing. Next page. These 6 problems are not going to take as long as you think. The first 4 are very quick. It's the 2 at the bottom that are going to take a little bit of time. So let's talk about the rules. These are the ones that are most commonly broken because they are far more strict than the multiply and divide. I'm going to zoom in here on the addition rule real quick, but adding and subtracting, they have the same rule as each other. So let's take a look at the 2 separate radicals here. They both have the same n, but they also have the same thing under the radical as well, an x. So not only do they have to have the same index, they have to have the same thing under the radical. The radicals must be exactly the same if you're going to do math with them, if you're going to add or subtract them. Same thing with the subtraction. They must have the exact same radical. If they don't, you can't combine them. It's a combining like terms thing. Just like the others, I'll write a little explanation about that. Once again, all we're really doing here is combine like terms. Whether that is adding or subtracting or a combination. Both terms must have the exact same radical. To add or subtract. Number 10. 3 times the square root of 5x minus 2 times the square root of 5x. They have the exact same radical. We can do this subtraction. Now, before we are tempted to do any math with the 5x's, I'm going to bring that radical down into my answer. Do not actually subtract the 5x's. The only thing we're actually going to subtract is the 3 and the negative 2. So do the 3 minus 2, which is 1. And then if you want to make your answer a little better, the 1 in front doesn't really need to be there. So we could also just say this is the square root of 5x. I'll add the little note here in case you missed it the first time. Do not subtract 5x and 5x. The stuff under the radicals, don't actually subtract those. See that more often than you would think. Number 11, 6x square root of 7 plus 4x square root of 5. Radicals don't match, and I can't break either of those numbers down, so this one's just not doable. Different radicals. Can't add. Questions on 10 or 11? 12? 12 cube root of 7xy minus 8 fifth root of 7xy. Same thing under the radical, but the indexes do not match. Different indexes. I totally butchered that spelling. Give me a sec. There we go. Different indexes. Can't subtract. Number 13. (17 cube root of 3x squared minus 15 cube root of 3x squared. The radicals are exactly the same, so we can do the math here. 17 minus 15. That's going to give me 2. And again, the radical just comes down. Cube root of 3x squared. These next ones require more work. Number 14, the square root of 12 plus the square root of 75 minus the square root of 3. We're not just going to look at that and say, oh, they don't match. Can't do it. You have to try dig a little deeper. Both of these, 12 and 75, can absolutely be broken down. So you have to break them down first, and then if whatever comes out of that can't be combined, then that's when you can stop. Oh, okay. I'll be right out. All right, number 14. So as I said, we need to break down the 12 and the 75. The 3 will stay as it is. And for space-wise, I'm going to leave the space under here available because as I break these down, I'm going to write the new numbers underneath. So we have a square root of 12. Reminder, this is a square root, so we're making groups of 2. 12 breaks down. 3 and 4 is probably the best way to go here. 2 and 6 would be good as well. So the 3 will stay, 4 breaks down, 2 and 2. We can make a group of 2 2's. And we have a lonely square root 3. We get a 2 out of that pair of 2's, so we have 2 square root 3 for that one. So above, I'm going to replace the square root 12 with 2 square root 3 plus, I'll do the same for the 75, square root of 75. I hope most of you think of 25 when you see that number, 25 and 3. The 25 breaks down into 5s. So we're done with the 25 now. Groups of 2, we have 2 5s here and a lonely square root 3. So we're going to have 5 square root 3 here. And then we'll replace the square root 75 with 5 square root 3 at the top. And lastly, we'll bring down that minus square root 3. Now we can magically do this problem. So let's take care of that. First off, I'm going to bring over the square root 3 into my final answer, so I'm not tempted to do anything else to it. Doing the math. Don't forget that this minus here, this is like a minus 1. A lot of students forget about that when there's just a plus or a minus a square root. They'll completely ignore it. So acknowledge that that's a negative 1. And then we can just combine like terms with the coefficients, the numbers in front. 2 plus 5 is 7, minus 1 is 6. So we end up with 6 square root 3 as our overall answer. Questions over 14. And this is more like what you'll see on the quiz, on the test, these kinds of problems. 15. Cube roots here. Once again, I'm going to set up my answer space. We'll start with the cube root of 250. $250 again ends in a 0, so I'm going to pull out a 10. And then the other number would be 25. 10 breaks down quickly, 2 and 5. 25 also breaks down quickly, 5 and 5. Groups of 3 here, since it's a cube root. I have one group of 5s. And then I have a lonely square root 2, cube root 2. So putting it together, and I'm going to do it down here because I need space for 3 on this problem. 5, and then don't forget the cube root on the 2. Above, I'll replace it. 5, cube root 2. Plus, and let's break down the 54. Cube root of 54. We've already broken down 54 today, so it's going to look the exact same, but it's a cube root this time. 6 and 9. Break down the 6 into 2 and 3. Break down the 9 into 3 and 3. And this is what we have left. Groups of 3. I have a group of 3s here and a lonely square root 2. So the group of the 3 will come out as a 3. The 2 will stay under the radical. So this gives me 3, 2, and again, this is a cube root. Replacing above, we have 3 cube root 2. Minus, and then we got to break down the 24. 24, this time I will go 3 and 8. Again, if you choose different numbers from me, you should still get the same answer, as long as they are multiples of 24. 8, we can go 4 and 2. And then the 4 breaks down into 2 and 2. I'm going to cross out 8 and the 4. I'm done with those. We're left with a group of 3 2s. So it's going to pop out a 2. And then don't forget the lonely cube, or the 3 at the top. Putting it all together, I have 2, the 3 inside of the cube root. And then one more time, I'll replace that up above. 2 cube root of 3. Questions on any of the breakdowns? We can go back and talk about any of them before we do the math. So let's take a look here. We have a cube root of 2, cube root of 2, and a cube root of 3. So I can only combine like terms with the first two. The last one, 2 cube root of 3, can't do anything with it. It's just going to be part of my answer. So I'm going to go ahead and write that in the back. Minus 2 cube root of 3. And then I'll combine like terms here. Again, the only math that we're doing is with the 5 and the 3. 5 plus 3 is 8, and then we'll attach the cube root of 2 to that. And that's all we can do. That's our answer. Questions on number 15? Let's turn it to the back. We do have 2 more problems to do of a different type. I would have put this with the multiplication section since that's what we're doing, but this is a combination of multiplication and add subtract, so it had to go at the very end. FOIL, aka double distributing with radicals. It works exactly with whole numbers. The process is the same. Some of the calculations will just look a tad different. So number 16, 5 plus the square root of 7 times 5 minus the square root of 7. Let's multiply. First thing I'm going to do is take the first number in the first set of parentheses, which is 5, and I'm going to distribute it into the second set of parentheses. 5 times 5, that's 25. 5 times negative square root of 7. First off, this is a negative. And then the 5 square root 7, you'll just write together. And we'll repeat that process with the square root of 7 here. Distribute it into the second set of parentheses. Square root of 7 times 5. This one is a positive. And again, just write them together. 5 square root 7. Be extra careful on this last one. This is the step that is the most prone to mistakes. Square root of 7 minus times negative square root of 7. First off, positive times a negative. This will be negative. Square root of 7 times the square root of 7, square root of 49. This is my result. From here, just like usual, the middle terms can be combined. So I have negative 5 square root of 7 plus 5 square root of 7. Now if I combine these, again, I'm going to have a square root of 7 in the answer. Negative 5 plus 5, what is that? 0. So when I add these, I'm going to end up with a 0. So I'm not going to put that in my next step. That's a little silly. If it's a 0, then it's gone. So these two actually disappear completely, and we just have 25 minus the square root of 49. Don't stop here. I hope you recognize square root of 49. That's a perfect square. It's 7. So we now have 25 minus 7, which is 18. 18 is our final answer here. Questions on number 16? One more, number 17. 4 minus 2 square root 5, whole thing squared. This is a very commonly missed problem. To start it off correctly, when you see this squared, I want you to think, write it 2 times. So I'm going to do that. We have 4 minus 2 square root 5. And again, 4 minus 2 square root 5. This makes sure that you set up a FOIL problem, a double distribute problem. And then I'm going to do the exact same process that I did in number 16. Starting with the 4, we're going to distribute it into the second set of parentheses. 4 times 4 is 16. 4 times negative 2 square root of 5. 4 times negative 2, you just multiply like normal. That's negative 8. And then attach the square root 5 to the 8. Repeat with the negative 2 square root 5. Distribute. Same way. Negative 2 square root 5 times 4. Negative 2 times 4, that's negative 8 again. Attach the square root 5. And then again, be extra careful on the last one. Negative 2 square root 5 times negative 2 square root 5. Negative 2 times negative 2 is positive 4. Square root 5 times square root 5 is square root 25. First off, we have those like terms in the middle we can combine. They both have square root 5, so I'm going to combine the negative 8s. Negative 8 minus 8, this one's not 0. This is negative 16. Negative 16 square root 5. Bring down the 16 and the plus 4 square root of 25. Some students do forget this step from here. This is not my final answer because I do have a perfect square in here that I can take care of. So let's take care of that. We know that the square root of 25 is 5. Remember, this is 4 times the square root of 25. That's what this means. So this turns into 4 times 5. Bring down everything else. 16 minus 16 square root 5, and then there's a plus in front of the 4 times 5. Couple more steps here. Next, I'll multiply the 4 and the 5 together. So we have 16 minus 16 square root 5 plus 20 and now I have another pair of like terms. 16 and 20 can be combined. They're both positive, so we're going to add. When we add that, we get 36. I'm not going to make a huge deal out of it if you don't do this, but the proper way to write these answers is to put the whole number that doesn't have a radical first. So if you're thinking about this as you write, make sure you put the 36 first, then bring this down. Don't do it the other way around. On a test or a quiz, though, that's not something I would take points off for. Now, this is our final answer. We have nothing left that we can do.